Hello and welcome to another video lesson with Mr. Roman. Today we're going to be talking about laws of exponents, part 2. So we're going to start here with the quotient rule. And the quotient rule says that you can take a base of x to the a power divided by the base of x to the b power. And to divide those, you could just simply say that that would be equal to x to the a minus b power. Okay, so you're basically subtracting the exponents when you're dividing two bases, or two of the same bases with exponents. So let's look at an expression that would be similar to this concept. So at the top of this fraction over here, you have x to the 7th power, and then on the bottom, you have x to the 3rd power. At the top, you've got expanded, so x to the 7th is x multiplied to itself 7 times. So that's what you see at the top of the fraction here. And then at the bottom, you've got x to the 3rd power, which is x multiplied itself 3 times. Now, if I want to simplify this, I can simply divide out the common factors of x. So x divided by x is 1, x divided by x is 1, x divided by x is 1. And what I'm left with on the bottom of this fraction is 1. And then on the top, I'm left with x to the 4th. So we really could write this as x to the 4th over 1 as a fraction, but that's not necessary. So our simplified answer would just be x to the 4th. The second example, here we're given 10 to the 8th power divided by 10 to the 3rd power. And we can see, again, expanding this out, we can see 10 being multiplied to itself 8 times, and then the 10 on the bottom being multiplied to itself 3 times. And the same concept, we can divide out these 10s to be 1. So 10 divided by 10 is 1, 10 divided by 10 is 1, 10 divided by 10 is 1. So on the bottom of this fraction, you're going to have a 1. And then here at the top, you have 10 to the 5th power. So again, you could write this as 10 over 1, or 10 to the 5th power over 1, I'm sorry, as a simplified fraction. But that's not necessary. We would just take this as a simplified expression. Next, when we look at the third example, we have x to the 10th power, and then divided by x to the 2nd power. So that's expanded 10 x's at the top, and on the bottom, 2 x's. So again, dividing out x divided by x is 1, x divided by x is 1. So here we're down to just a 1 on the bottom, and we're left with 8 x's on the top. And we could treat this as x to the 8th over 1. But again, this would be our simplified answer. So next, when we have an expression that has not only a base with exponents, but also coefficients, so the coefficients here being the 30 and the 5, then we can also divide out those coefficients. So here you see in the expanded version, I just multiplied out all the a factors at the top and then all the a factors at the bottom. But down here in this next portion, what I'm showing you is 30 divided by 5. That's where we're going to get our 6 in this simplified expression. And then from here, we get a divided by a is 1, a divided by a is 1, a divided by a is 1, a divided by a is 1. And so here, that's where we get a to the 2nd power over here. And so the question is on your notes, what pattern did you notice in the table above? Well, the exponents are being subtracted and the coefficients are being divided. So notice if we took a to the 6th minus a to the 4th, so that's 6 minus 4 gives us this 2 here. And then we took the 30 divided by the 5, that gave us the 6 here. So that's a practical application there. Let's see another example of what this looks like. So here, we're just going to erase what we've got just writing-wise. So you could have everything at the top, m to the 3rd times n to the 10th. I went ahead and wrote that out up here at the top of this and expanded it, and the same thing on the bottom. So again, when we're dividing out these m's, m divided by m is 1, this is 1, and then here we've got all these n's here, 4 of them will divide out with 4 of the n's here, and you'll be left with 1m here, and then n to the 5th power. So that's where we get this expression over here. Okay, so letter B in your notes, you can see everything inside these parentheses here is to the third power. And remember, there's an understood 1 that sits above this exponent right here. Or I'm sorry, above this base right here. So first, we're going to just focus on simplifying inside the parentheses. We're not going to worry about this cubed just yet. So first, we're going to take the 14 divided by 2, which is going to give us this 7 over here. And then we're going to take a squared divided by a, which is going to give us a to the first power over here. Now, remember, everything is still inside the parentheses, and it's to the third power. So we've got to keep that power of 3 on the outside. Now, from there, I'm showing you the expanded version down here, where we've got 7 times a times 7 times a times 7 times a. And I'm just rewriting those over here to the right. So putting all the 7 coefficients together and putting all the a factors together. 7 times 7 times 7 is 343. And then a times a times a is a to the third power. And then in this example, we're given that 5 to the 6th power divided by 5 to the 6th power. We know that any number divided by itself is always going to be 1, but I wrote this out and expanded it so you could see all of these 5s just divide each other out, and you're left with the top as 1, and the bottom of the fraction is 1. And we know that 1 divided by 1 is simply this 1 here. Okay, so the zero exponent law or rule, it says that any base with a 0 power is equal to 1. So when a term has a 0 power or a power of 0, it is always going to be equal to 1. So what we can look at then here would be that inside the parentheses here, x to the 0 power, that's just going to be this 1 down here. And then we know that 1 squared, so that's this portion, is going to be just 1 again. So here we get the simplified answer of 1. Next, this is inside the parentheses, we have all of this stuff, but really it doesn't matter because everything in the parentheses is to this 0 power. So that means that everything is going to be equal to just the 1. So that's why our simplified answer here is 1. Now, this rule is a little bit more interesting because a negative exponent simply means that we can take the fraction of whatever it's creating and flip it to turn that exponent positive. So, for example, here, we would say x to the negative a power. This is over a fraction of 1. Okay, we can always write it over 1. That's actually going to be equal to, if I flip this over, so the 1 being on the top and then the x to the a on the bottom, that's called a reciprocal. So we flip it over, it's a reciprocal. But notice the a turns positive when we do that. And the same is true over here. So over here we can say this is x to the a power over 1. And this is 1 over x to the negative a power. Well, if I want to flip this fraction over, I can turn this exponent positive. Okay? And those are equivalent expressions. So what we have here is when we're multiplying x to the 4th power, and we multiply x to the negative 6th power, that gives us, adding the exponents, right? We're saying 4 plus negative 6, that's going to equal negative 2. But remember, this can be written as a fraction as x to the negative 2 over 1. So if we wanted to rewrite it, we would flip the fraction. So that would be the reciprocal. And then this 2 turns positive. Okay, so then the next example we have is 5 to the negative 7th power. So remember, this again could be treated as 5 to the negative 7th power over 1. And if we flip that fraction over, 1 goes on the top, 5 to the 7th power, and the 7 here turns positive when we do that. And then in this case, what's interesting here is we've just got the x to the negative 9 power. That 3 is kind of, it's not really be affected by that law. So let's rewrite this as two separate fractions where we would have the 3 over 1, which is this first portion here. And then the x to the negative 9th power we can write as 1 over x to the negative 9th. Now, if I use that property that we just described on this portion, I'm going to flip that fraction, and I'm going to turn that x to the 9th as a positive exponent. And now you can see that I can multiply straight across this top, which is where we get 3x to the 9th power here. And then on the bottom, you just have 1. So we could treat this as 3x to the 9th over 1, but again, that's not necessary. So we would just say 3x to the 9th. This next example, same concept. We're going to break this apart as two separate fractions, and we would treat it as m to the negative 4th power over 1, and then 1 over m to the 3rd power. And so here, this portion, we can flip over, we can do the reciprocal, and we can turn that m to the negative 4 as a positive. So that's what I've shown right here, 1 over m to the positive 4th power. Now, if I'm just multiplying across the top of the fraction, here I would get a 1 at the top. And on the bottom, I'm going to get m to the 7th power. So m to the 7th power here, which we know is also equivalent to flipping the fraction and making that exponent negative. So we could treat this as m to the negative 7th over 1. So either one of these here or here would work. And then this example, here we're going to start with just simplifying what's inside the parentheses. So you can notice that there's some stuff to simplify. We're going to start with the 16 and the 2 here. That's going to turn into this 8. And then we're going to turn the a to the 5th and the a to the 4th. That's going to simplify to be this a over here. And then the b to the negative 2 power, we're just going to kick that down to the bottom of the fraction. So that's where we get this. Okay, so now what we're looking at is all of this stuff to the negative 3 power. And we can really treat this powers to powers here as like the distributive property for exponents. So there's an understood 1 exponent here, a 1 exponent here, and a 2 exponent there. So when we would say negative 3 times the 1, that's where we get this exponent. We'd say the negative 3 times this 1, that's where you get this negative 3 exponent. And then the negative 3 times the 2, that's where you get this negative 6 exponent. So now, remember, any negative exponent terms, you can flip to the other side of the fraction, and they turn positive exponents. So this guy here went to the top of this fraction, turned positive. And then the same thing happened with the a's down here. And then the same thing happened with the 8 base here. And then our last example on your notes. Here, again, we're given an expression of all of this stuff inside parentheses to the negative 2 power. So we can actually distribute that negative 2. And we're going to start with the 20. Here, it's understood that there's a 1 exponent on this 20. So the negative 2 times the 1, that's where you get this negative 2 power. The negative 2 times the 6, that's where you get this c to the negative 12th power. And then the negative 2 times the negative 10 is where you get this positive r to the r to the positive 20th power. And then when you have the negative exponents, remember, those can shoot down to the bottom of the fraction, which is where we get this bottom portion here. And this concludes our video lesson.